Hello everyone, with this one I'm publishing my second video which demonstrates the control system and its PLC programming with Siemens TIA portal. Let's start quickly with the application. We have a basic ventilation system here with two fans. These fans start whenever the S1 push button is pressed. The logic is with the first press only fan 1 starts running, and with the second press fan 2 also starts running, and with the third press both fans stops running. I will write the PLC program two times. In the first one I will use latching function, which is simple and popular actually at the beginning of programming, but with the second programming I will use positive edge triggering block. Unfortunately I will not talk about positive or negative edge logic because I believe there are a lot of information in the internet and they are very detailed. In order to keep the video short, I will focus on explaining the application procedure and how to program it in my videos. I will write my program into the function block as I did it in my last video. For the complicated examples, it's better to write them in a function or function block. So I put the wiring diagram in a snipping tool so we can overview easily and write the program. Here we have our S1 button. It is normally open contact and it is series connected to the normally open auxiliary contactor K11 and to the fan 1 contactor, and it is also connected to the K13 contactor. So whenever K11 is activated, it goes here and it closes contacts here, then fan 1 is activated. The same thing is here for the fan 2. It is activating the K12 and latch itself here, then here it closes its contacts and transmit the power to the fan 2 contactor and starts the fan 2. Let's start the right programming. So first we will write this part. I have at the beginning S1. First I want to write my data so I can name them or take them easily, and also let's create the PLC tags first. It will be easier for us. We have one input here and two output, so it's a very simple application, to be honest. S1 our input, Q1 output for fan 1, so we can come back to our block again. I have S1 input. I have as output I have Q1 and Q2, but I am using them as input also, so I will write them in an out part. So the other thing is I use K11, 12 and 13 as auxiliary, and I use them as static because they keep memory for me. So we are finished with the naming them. We have S1 as parallel, Q1 and K11, and K13 as series. Let's write it. This is S1. According to my wiring diagram, I finished this part, S1, and it is series with the parallel of Q1 and K11, and it is also series with the normally closed contact K13, and finally gives output to K11, and it latches itself. This is activated and keeps giving energy until S1 is pressed back. It will zero again, but when this is energized, this is also normally closed contact, and Q1 is also latch itself and continues running. I'm moving to the second part for the second fan. S1 again. I also finished the second part. Here S1 again, and comes the series connected series to do this parallel part. Here they are, and K12 comes here. It latches itself here, and it also helps to do Q2 as auxiliary contact. Contacts close, and it's energized. It's also latches itself and keeps running the fan too. Let's move on. We will use this part as our resetting part, stopping the fans whenever the third one is pressed. Since fan 2 is running, this is a close contact, and whenever S1 is pressed for the third times, this will be energized and it will energize K13, and here it will latch itself, and when it is latching itself, this will be open, normally open contact, and both Q1 and Q2 will not receive more power, then both fans will stop running. So this part is also finished. Let's write this area also. This part is also finished. I have made both of them. For resetting and running the fans, we need K13 auxiliary contact. I just noticed that this is supposed to be a normally closed contact. Let's save our project and put it in. Put our function into the main block. It will create a data block. Since it is a function block, it needs memory. It uses memory. Then let's name them. It is easy. We already made it. Q1, Q2 for fun. So now we can use the simulator to see if our program is running or not. Our PLC scene is ready. Let's add our PLC text table. We will be easily simulate our program. It is working correctly. Now let's go online and let's monitor from the main log. So when I first press my push button for the first time, Fan1 is supposed to be running, and when I press the second times, Fan1 is supposed to running together with Fan2 will run with Fan1, and if I press for the third time, both Fan will stop. So let's try the simulation by going online. Let's monitor the block and try. Didn't work. Now let's see the what is wrong. The addresses are yeah, these are output actually, but I will fix it now. Here they are supposed to be output. Let's compile again and download the program to the simulated PLC. Now it seems correct. Let's try again by going online and monitoring it. So I try for the first time and I see Fan1 is also running. You can also see from here value. Now I will press for the second time. This is a push button. I need to push 2 times to use it as a push button. So I press second time and Fan2 also start running. So if I press again, they are supposed to be stop running and they will turn in false. Yes, as you see, it is working. So our program is correct. The only thing was the PLC tag table was not supposed to be like input for the funds. So now I will change into the other project to make the programming with positive edge triggering. Doing with the positive edge triggering function. This time I will not use the wiring diagram because we already know the logic and it is will be actually a little bit easier. I will create again function block to write my ladder diagram. As I said, I will use a positive edge triggering. I will trigger the positive edge with the S1 button, and let's take our function, and this will also trigger the temporary bit, which helps us to run the fun1 and fun2. So in order to do it, I will also write my bit names S1, and I will not use output, but I will use in and out. And 2. And for static, I will name this P. And I will take here. So let's carry our names. So I will use a temporary bit for this output. I will name it TO, temporary, or TO. It's assigned. So whenever temporary output or our positive edge triggered, we will also set our fun. So I will use this in my second network, which will trigger my first fun. However, there is another condition. First, fun 1 should not be running already. So in order to verify it, I'm adding a normally closed contact here. Sorry, it will be first fun again. But in order to use positive edge, I need to reset this help auxiliary bit. Otherwise, when I push the second time to the S1 push button, this will not set our temporary output because it will be already set it. So let's reset it as parallel. This is going to be reset. And what I forget here, this is going to be set. Otherwise, pardon. Otherwise, when I reset temporary output, this will be false again, and it will stop my first fun. And let's continue for the fun 2. Same logic here, and again, it should not already running. And let's set it. Let's set the fun 2. And again, we should reset our temporary bit. I pressed for the first time positive edge triggered, and it set 1 TO. Since it is false already, this will set my first fun, and it will set TO to reset TO, so I can use it for the second press to the push button. I did the same logic here, and now what I should do, I should reset these fun 1 and fun 2 when I pressed for the third time, so they will not run anymore. I will take the TO again here, assign it. Now I have to reset fun 1 and fun 2. So let's put it in our main block, and we didn't create our tag table. It was just 3 input and output, as you will remember. Let's make it output and fun to save our project, and let's start our simulator. The assessing is ready. Let's create a new project. Let's say validation. Okay, TE sim positive edge simulation. And PLC sim is ready for our simulation. Let's set the sim table. Sorry, this is the wrong one. And let's compile again and download the program again, just to be sure. It will not take so much time. It's already up to date, but and we can go online and monitor our main log. So for the first press the push button, it will switch on the first one. Let's try it. Something is wrong. Let's check it. See, we didn't assign the inputs and outputs in our main organization block. So this is S1, this is obvious, Q1 and Q2. We need to compile and download again. So I will go online one more time and monitor it. Now we can try again. First press the push button, and as you see, it turned on true. So second press onto the push button. So both fans are running now. With my third press, they have to stop, and they are false again. So you see the programming and you see the application. This wasn't a difficult one and simple with only two fans, a ventilation system. You can make it more complicated by adding more fan or temperature sensor also. Maybe we will do it also with the next videos. So for now, I thank you, each of you, for watching and bearing with me for this long video. And I say see you on the next video. Bye.